Hi, I'd like to walk through Homework 6 Part 1 question number 2 just to show us how we can use or show you how you can use your Google Sheets calculator to make your life a little easier um, for finding test statistics and probabilities. So I'll read the question, highlighting a couple words here. It says, is college worth it? Part 1. Among a simple random sample of 331 American adults who did not have a four-year college degree, and are not currently enrolled in school, 48% said they decided not to go to school because they could not afford it. A newspaper article states that only a minority of the Americans, so we'll have to come back to this word in a second, who decide not to go to college do so because they cannot afford it, and uses the point estimate from the survey as evidence. Conduct a hypothesis test to determine if these data provide strong evidence supporting the statement. Um, so first of all, we have to figure out what information we're given. We're given the sample size. We are given our population, our sample statistic here, so our p hat, we're given that. And we have this word minority, which tells us we are just comparing something to 50%. So minority means that we're dealing with something less than 50%. A majority would mean more than 50%. So that is why we are saying the proportion, the population proportion or the population parameter here is 0.5 because we are comparing it to 50%. And I've chosen this one because I want it to be less than 50%. The main purpose of this article is just to show you that you can use your Google Sheets in case you didn't realize that. For this problem and for many other problems, it's going to make it a lot easier. So you can also do them by hand if you want to calculate z-scores by hand. Totally fine, no problem with that. Maybe you'll understand it better. Seems good. Anyway, so I've opened up my Google Sheets here, my Google Sheets calculator. I like calculating z-scores by hand. Do it all the time. If you see this tab here, it says hypothesis testing. That's what we're doing now. So I've gone ahead and highlighted that. You might also notice the tab that says confidence intervals. That might be useful when making a confidence interval. Um, we are doing one proportion. I've already got my sample size in here. I've got my null proportion in here too. We've already said that p hat is 0.48, right? So I could just type in 0.48 here. I want to talk about what x means though. X is the number of successes. What is the success for this problem? A success would be a success is like in quotes, right? Because it's kind of a strange thing to call a success, but it says success for this problem would be a person who said they decided not to go back to college because they could not afford it, right? That's the thing we're keeping track of. We're trying to keep track of if people are going back to college because they can't afford it. It's not given to us here, but we can find it if we wanted to. We could say equals 48%, so 0.48, 48% of the sample, right? Of the sample size, so times this. Um, this problem is weird because you're probably thinking there can't be 158.88 adults. That's impossible. And you're right. And that's the reason that works out is partly because this is a rounded number, but also because this was just it's a problem that some other professor made, and they put in x value that didn't work out perfectly. I'm sure it's just because this is a rounded number. Anywho, the calculator spits out our p hat for us. It's 0.48, and it also spits out a bunch of other stuff. So we'll talk about that. Um, our test statistic is the z-score that we would have computed. If you're computing this by hand, that's fine. You can see that in Chapter 6, how to compute it by hand. If you have questions on how to compute it by hand, I'm happy to type out the computation and put it into a forum somewhere. I've already typed out a couple in the forums, but I can type out more. And now we've got to figure out, we've got three different p-values. We have to figure out which one to pick. And what one we pick is going to be dependent on which hypothesis test we've chosen here. We'll start with this one, the two-tailed p-value. We would choose that if we are saying that the population proportion is 0.5 and that our alternative hypothesis is that the population proportion is not 0.5. So this would be a two-tailed test, and that would be the probability given there. But that's not the probability we want. We want the probability that our population proportion is actually less than 0.5, and that's actually going to be a left-tailed test. You can tell because it's less than here. That's 0.233. If we had chosen a right-tailed test, that would be this one here. So greater than will always be a right-tailed test, less than will always be a left-tailed test. And these two numbers, you'll notice what is happening. Don't do that. These two numbers, you'll notice, are complements, right? You add them up and they get up to 100%. You'll also notice that the left tail, if you take that and multiply it by 2, you get the two-tailed one, right? So yeah, so that's where those numbers are coming from. So this is the number we want. This is the p-value associated with this hypothesis test. Our test statistic was the z-score that we would have computed. We've got all these choices now. So alpha is not given to us. So what we're going to do is we're going to say alpha is 0.05 in general. And 0.05 is our cutoff for this. So if I type that out here, right, just so I'm saying these words, but it's sometimes easier to see them. And the p-value we got is, I'll just copy it from right here. Copy, paste. Oh, that's not what I expected. Let's try that one more time. Copy, paste. My goodness. My goodness. Something strange is happening. I'm just going to type it. 0.0. I probably typed something in there before and everything got crazy. So this is my p-value, right? This alpha is our cutoff. So if our p-value had been less than 0.05, we would reject the null hypothesis. But it's greater than 0.05. It's like 23%. So we will fail to reject the null hypothesis. And so let's look at our choices. Here we can see that the p-value is bigger than alpha. So we reject the null hypothesis and accept the alternative. Well, that's not true, right? First, well, we just said that p is bigger than alpha, so we should not reject the null hypothesis because it's probably right. This we don't need, that we don't need. This one, p is greater than alpha. We do not have enough evidence to reject the null hypothesis. Yeah, that sounds great. We don't have enough evidence to say that this is incorrect. And then it says, this last one is tricky. This last one says p is great, our probability, our p-value is greater than alpha. We accept the null hypothesis. And that seems weird because that seems almost the same as this one, but we always want to be testing the null hypothesis. We never really want to accept any number and then just say, okay, this is definitely the true proportion. Let's move on, because the proportion might change, right? So this is why we don't pick that we're accepting the null hypothesis. Let's take just a moment. Let me pause and collect myself here. All right, let's talk about what this number means. I kind of glossed over that. This 0.233. This is almost 25%. I'm stretching a little bit, but imagine it is 25%. What we're saying is there is a 25% chance if the true proportion was 50%, there is a 25% chance that we would have gone out and asked 331 Americans why they are not going back to college, and 48% of them would have said they're not going back because they can't afford it. There's a 23% chance of that. It's almost a 1/4% chance, or a quarter chance. Oh my gosh, me and my words. So I'll say it one more time. There's a 23% chance that if this is true, we would go out into the world and ask 331 American adults why they're not going back to college, and 48% of them would have said they're not going back because they cannot afford it. So that's what that number means. So that means that like this is likely to be true because there's a pretty high percentage chance of that thing that we just did happening. Anyway, it says interpret the results of the test in the context of the study. It says the data do not provide sufficient evidence to claim that only a minority of Americans who choose not to go to college do so because they cannot afford it. And then it says, would you expect a confidence interval for the proportion of American adults to include 0.05? And yes, we would, because if it didn't include 0.05, this would be a much, much smaller p-value. It would be super small. Or it would be smaller than alpha anyway. It would be smaller than 0.05. Anyway, the main goal was to show you how you can use this spreadsheet to do some computation. And you don't have to do everything by hand, although you're welcome to if you want to. If you have any questions, post them to the forums. Thanks.